We are going to start question number 8. With respect to the origin, the point A and B have position vector 2i plus 4k and 5i plus j plus 6k respectively. The line L1 passes through the point AB. Find the vector equation for the line L1. Okay, we know that to find the vector equation of line, we need a point and direction. So we can have the equation like point A plus lambda time direction vector. So direction in this case can be find out by using the point A and B. So first we find the direction. First we find the direction. Direction is equals to the AB, and AB are given, which is equals to B minus A, and in this case B is 5i plus j plus 6k minus A, which is 2i plus 4k. So we have 5i plus j plus 6k minus 2i minus 4k. Solving further, we will have 5i minus 2i is 3i plus j 6k minus 4k is plus 2k. So we have the direction, and the equation of line is a point A plus lambda minus t. So in this case we have the A, which is 2i plus k, 2i plus 4k plus lambda time d, which is the direction, and which is 3i plus j plus 2k. And we can write it in this form also: 2 0 j value is 0 and k is 4 plus lambda time 3 1 2. This is the equation of line, vector equation of the line. Okay, now let's move to the part B. The line 2 has the equation r is equal to 2i plus j plus 5k plus mu time I plus 2j plus 3k. Show that L1 and L2 do not intersect. To prove either they have intersecting point or not, we will first write the equation L1. So L1 is equals to the 2 plus 204 plus lambda time 312. Further solving, we will have 2 plus j values are 3 times lambda, which is equal to 2 plus 3 lambda. And j terms is 0 plus lambda time 1, which is equal to lambda. And we have the k term are 4 plus lambda time 2, which is equals to the 4 plus 2 lambda. This is the components of the L1. Now let's find the component of R, which is equals to the 2, component of J is 1, and component of K is 5 plus mu time component of I is 1, 2 and 3. We can write it in this form: 2 plus mu 1, and this one is 1 plus mu 2, and this one is equals to 5 plus mu 3. Okay, we can write it 2 plus mu, this one is 1 plus 2 time mu, and this one is 5 plus 3 mu. Okay, if L1 and L2, this one is L2, has the intersecting point, we will equate the ij component of L1 and L2 simultaneously and find the value of lambda and mu. Now, to find the intersecting point, we will first compare the I component, j component and k component of the L1 with the L2. So this one will be compared with I component. This one is j component, and This one is k component. Comparing these components, so we will have 2 plus 3 lambda is equals to 2 plus mu. Now compare the j component, we will have j is equals to the 1 plus 2 mu. And we will compare k components, so 4 plus 2 lambda is equals to 5 plus 3 mu. So we have the three equations and we will find the values of mu and lambda from first two equation and plug in third equation. If it satisfies, so we will have the intersecting point. If they don't satisfy, so we don't have intersecting points. First compare equation 1 and equation 2 simultaneously. From equation 1 we will have 2 will be cancelled out and we will have mu is equal to 3 lambda. And plug this mu value in equation 2, plugging mu is equal to 3 lambda in equation 2. So we have equation 2 which is lambda is equal to 1 plus 2 mu, plugging the value of mu which is equal to 3 lambda. So lambda is equal to 1 plus 2 times 3 lambda, and this one is equal to lambda is equal to 1 plus 6 lambda. Solving further, we will have 5 lambda is equal to -1 and lambda is equal to -1 over 5. So we have the value of lambda, plugging this lambda value in equation 1, which is this one, to find the value of mu. Plug lambda is equal to -1 over 5 in equation 1. So we will have mu is equal to 3 times lambda, and in this case lambda is 3 times 1 over 5 negative, and mu is equal to -3 over 5. So we have the value of lambda and mu. Okay, we have find out the value of lambda and mu. Now plugging this, we will plug these values in equation 3 and find out that these values satisfy this equation or not. So we have the equation, this one is 3, plugging lambda and mu in equation 3. So we have equation 4 plus 2 lambda is equals to 5 plus 3 mu. So we have the values 4 plus 2 times lambda is -1 over 5 equals to 5 plus 3 mu, which is -3 over 5. So solving further, we will have 4 minus 2 over 5 is equals to 5 minus 9 over 5. So in this case, we will have 20 minus 2 over 5, which is equals to 25 minus 9 over 5. And we will have 18 over 5 on the left side and 16 over 5 on the right side. So left hand side and right hand side are not equal. So we can say that L1 and L2 do not intersect. Now, okay, let's move to the part C. Find the acute angle between the direction of L1 and L2. So we have the direction of L1, which is L1 direction is D1, which is equals to the 312 3i plus 1j plus 2k. And L2, direction of L2 is R, which is equals to the, okay, this one, 1 plus 2 plus 3. So we can say that 1i plus 2j plus 3k. Okay, so we can call it D2. And we know that to find the acute angle between the direction of L1 and L2, the formula is cos of theta is equals to the D1 dot product of D1 and D2 over magnitude of D1 times magnitude of D2. Okay, so we have the D1 and D2. So we find first dot product. So first we find dot product. In dot product, we multiply the I component with I component, j component with j component, and then add up them. So 3 times 1 plus 1 times 2 plus 2 times 3. Solving further, we will have 3 plus 2 plus 2 plus 6. So we have the dot product d1 d2 is equal to 2 plus 3 plus 6 is 11. Now we find the magnitude of d1. d1 magnitude is equals to the under root square sum of the square of the ij k component. So d1 is 3 plus 1 and 2. So 3 square plus 1 square plus 2 square. Solving further, we will have 9 plus 1 plus 4, which is equals to the under root 40. Similarly, we find the magnitude of the d2, which is equals to the square root of the sum of the components. So 1 is plus 2 plus 3. So you can say that 1 square plus 2 square plus 3 square, and this one is equals to the 1 plus 4 plus 9. Further solving, we will have 14. So we have the magnitude of d1 and d2. Plugging these dot product values and the magnitude of the d1 and d2 in equation 4. So we can find the acute angle between L1 and L2. So plugging d1 d2 dot product value and d1 magnitude and d2 magnitude in equation 4. So cos of theta is equals to the d1 dot d2 is equals to 11 over magnitude of d1 and magnitude of d2. So 11 over under root 14 times under root 14, and this one is equals to 11 over 14. So we have this one is cos of theta. So theta can be found out cos inverse of 11 over 14, and this one is equals to the 38.2. So we can say that acute angle between L1 and L2 is 38.2.